Okay, let's just jump right in and tackle a truly terrifying primal fear. It's something that crosses every frequent flyer's mind at least once, right? What actually happens if your plane runs out of fuel 7 miles above the ground? Well, in this explainer, we're going to break down the myth versus the reality of a mid-air fuel crisis. And we're going to keep it really concise, short, sharp, and entirely focused on the facts.
Think about that feeling, that absolute anxiety of running out of gas in your car. It's incredibly stressful. Now, take that exact same panic and multiply it by 35,000 feet of altitude. Gravity is constantly pulling at you, and the nearest gas station is, well, miles below on solid ground. It really brings up that terrifying hypothetical, what if I literally fall out of the sky?
Well, it's time to bust a major Hollywood myth. Movies absolutely love to show fuel-starved planes plummeting nose first like a stone, right? But the reality, it's actually a whole lot more reassuring. The moment those engines lose fuel, yes, you lose thrust, but you do not lose lift. The wings are still wings, the air is still air, and your massive commercial airliner just magically transforms into a very large, very heavy glider.
The secret here is something called the modern glide ratio. For commercial jets, it's roughly 15 to 21 to 1. So to put that into perspective, for every single mile of altitude lost, the plane can actually glide forward up to 20 miles. So if you're cruising at 35,000 feet, your plane can comfortably coast anywhere from 60 to 130 miles without a single drop of fuel. Honestly, that is usually more than enough range to find a runway. And history absolutely proves this. A total loss of fuel doesn't automatically mean disaster. Take 1983, for example. The famous Gimli glider lost fuel just because of a simple metric conversion error, but it safely glided over 60 miles to a decommissioned base. Or in 2001, the Azores glider coasted 75 nautical miles over the Atlantic after a severe leak. Now, while rare tragedies do happen, like Avian Flight 52 back in 1990, where holding patterns and miscommunication tragically led to a crash, these events are incredibly rare today, mostly thanks to really strict modern flight planning. So what do the pilots actually do when the tanks go completely dry? Well, they don't panic. They execute a super strict 4-step checklist. First up, try to restart the engines, just to check for a temporary fuel imbalance. Second, and this is absolutely crucial, they deploy the ram air turbine, affectionately known as the RAT. It's this tiny, literally life-saving propeller that drops right out of the plane's belly. It uses the rushing air to generate just enough electrical and hydraulic power to keep the flight controls alive. After that, they pick the best available runway, and finally broadcast a mayday call to air traffic control. Now, a really crucial point here is understanding exactly why engines stop in the first place. You see, there's a vital difference between fuel starvation and fuel exhaustion. Starvation means the fuel is right there in the plane. It's loaded up, but mechanical faults are blocking it from reaching the engines. Exhaustion, on the other hand, is the total absence of fuel, usually due to massive distances or severe miscalculations. Now, while commercial flights can just take layovers to avoid exhaustion, military operations, well, they don't always have that luxury. Which brings us to a pretty radical, high-stakes solution. To entirely prevent fuel exhaustion on long or just really unpredictable missions, military jets and VIP aircraft, we're talking planes like the President's Air Force One, use mid-air refueling. I mean, they literally rely on flying gas stations. Now, to actually transfer that fuel mid-flight, you need one of two absolute engineering marvels. First is the flying boom system. This uses a rigid, highly stabilized pipe that's actually operated by someone physically in the tanker. It pumps a massive 1,000 gallons per minute, which is perfect for giant bombers. Then there's the probe and drogue system. This one uses a flexible hose capped with a funnel that kind of looks like a shuttlecock. It pumps a bit slower, maybe around 600 gallons a minute, but the trade-off is it allows a single tanker to refuel multiple smaller jets at the exact same time. As you can probably guess, getting the fuel from point A to point B up there is a highly orchestrated dance. The receiving aircraft has to fly directly behind and just below the tanker. They have to maintain this highly pressurized, absolutely rock-steady position directly in the tanker's turbulent slipstream. And remember, they're doing all this while hundreds of gallons of highly combustible fluid surge right between them. Naturally, flying two planes this close together introduces some pretty terrifying risks. You've got mechanical failures, things like hoses refusing to retract or fuel pumps just completely breaking. Then you have the extreme external hazards, hardware smashing together, improper alignment, and, of course, the absolute worst-case scenario, We're talking mid-air collisions or spatial disorientation, which is incredibly deadly when you're flying at hundreds of miles per hour, especially in the pitch black of night. So how do they mitigate these massive risks? Well, military pilots rely on really rigid safety protocols. They fly in strict, pre-established formations to prevent collisions, and they utilize autopilot to perfectly monitor and match their relative speeds. They also use specially designed dimmable exterior lighting so they don't blind the receiving pilot during those night ops. And crucially, not a single drop of gas is pumped until a mathematically verified, completely secure seal is confirmed. Which really leaves us with a fascinating final thought here. If mid-air refueling is so perilous, so expensive, and requires such incredible precision, why risk it at all when you could just, I don't know, move the airport? Seriously, sometimes the safest workaround to fuel exhaustion is simply moving the runway itself. By stationing massive aircraft carriers right in the middle of the ocean, militaries drastically reduce flight distances. They essentially act as floating oases. It really makes you wonder, as aviation continues to evolve, what other impossible geographical problems will we solve simply by taking the ground with us?